Hi, everyone. This is Sebastian Traeger, Managing Director with Reliability. We are back with another episode of Reliability 4.0. As always, we're on a mission to help make the world a more reliable place. And today I am really excited to be joined by Esther Voort with Anthony Veder from the Netherlands. We are thrilled to have you, Esther. Thank you for joining us today.
Thank you for having me, Sebastian. Thank you.
Absolutely. Well, your company is just very interesting. I mean, obviously, you do kind of a very specialized thing. So tell us a little bit about what the company and the business does, and then your role within it.
Well, at Anthony Veder, we're a gas shipping company. So we transport petrochemical gases and LNG worldwide with 28 ships in the small scale, medium scale segment. I think the special thing about of Anthony Veder is that we're an integrated shipping owner. So we have our new building program, we have our ship management department, our own crewing department, safety and quality procurement, but also our own commercial department. So yeah, I think that makes Anthony Veder a special company in that way, in an exciting business.
Absolutely. So 28 ships. Give us a sense of the scale of the largest ships that you all have.
The largest ships are around 35,000 cubic meters of liquefied gas that they can transport. So about 180 meters long.
Okay, so 180 meters for folks like me who are in the US and aren't great at the metric system, that's approximately 600 feet long is what that ends up being. That's amazing. So 2 football fields. That's how long they are. How often do you get on the ships?
Not as much anymore as I used to, but about 4 to 6 times a year. I have the option or the possibility to join for 1 or more days.
Okay, great. Yeah. And you serve as the reliability manager. Just want to understand, how did you kind of end up becoming a reliability manager with 28 ships that are 2 football fields long? How did you kind of get there?
The first time I got in contact with the company Anthony Veder was in 2004 as an apprentice. So I did a study of maritime officer, that's maritime engineer, deck officer in the merchant marine. So I sailed as an apprentice on 2 of these ships, and then did a study in logistics with maritime management, and then got a call end of 2009 from a friend of mine, colleague now, and he said, well, we have a vacancy at the safety and quality department, and I joined. So that's almost 16 years ago now. And quite a long time. I worked at that department, did a lot of incidents, safety incidents reporting, internal audits, guidance of new tonnage into the fleet, and later on moved to the technical operations department where I supported the senior superintendents, and then got the option to become a maintenance engineer, a reliability engineer. And from there built my own team, and now managing that team as a reliability manager.
That's great.
Yeah. So the thing is, we're another part of the operational technical team. So we have the day-to-day business in our technical operations team with our vessel managers for the ships. And we are, as a reliability and maintenance team, looking more at the long-term strategic goals to increase the reliability of our fleet.
Great. That's great. Well, and I'm going to drill down a lot more on what you do, but the kind of how you got there. So you mentioned that you kind of studied, or you were in the maritime world before the business. Is that just in the Netherlands because of the proximity to the water? Is that like a pretty normal path, or was it unusual that you would go into that?
Not completely unusual, I would say, and also not because I was born and raised near the port of Rotterdam. My family always had a connection with shipping in the Navy or with inland ships. My father always had a great interest of shipping, so when I had to look for a study after high school, I ended up at a maritime school, and I was so enthusiastic that I said, yeah, this is what I want to do.
That's great. Okay, so kind of a general familiarity. Well, let's turn now to kind of the what you do in the role. So what are kind of the top priorities that you focus on in the role in the business that you're in?
What we do with our team on the maintenance side is that we have a group that is managing our CMMS system, making sure that the maintenance jobs are in, that our spare parts are in, that if changes need to happen, that they manage that in a way that all the changes are done. On the reliability side, we look with criticality analysis on what are our critical systems on board, what spare parts would we need to have on board or another location, making a decision model where to put those spare parts. And then we have technical incident investigator in our team as well. So if we have technical defects, he is the one who helps us in the root cause analysis. And he teams up there with the people on board, the engineers on board, and with the vessel manager in the office to get to the bottom of the incident. And also there, the preventive actions are fed back into our CMMS system.
That's great. So I would imagine you've got a unique challenge. You've got ships out at sea, and you're obviously trying to predict spare parts they're going to need, but surely there's times when they don't have what they need and they're out at sea. Is that a problem that you run into? Is that a frequent problem, or the challenge is making sure that doesn't happen, I suppose?
Time to time, it is a challenge that you don't have the right spare parts. Positive, or the benefit we have, we are most of the times in a short sea trade. So within a few days, we are in a port. But it can be a challenge for the operational team to get those spare parts on board. What we also see now is that lead times become higher, so longer. So we have to wait longer between ordering parts and get them in our warehouse to ship them on board. What means that we have to look also more critical on where do we stock our spare parts, put them on board or put them in a warehouse location, or make agreements in our contracts that we can have a shorter lead time on that. So yeah, that there is a model that my reliability engineer just finished to look at lead times. How often do we use this material in our daily or our routine maintenance, and on how many ships do we need it? So by that, we can make a decision to put it on the best location.
That's great. It's good. A few years ago, you contributed on a paper thinking through, and it's kind of along the lines of what you just described, kind of a model to think through optimizing maintenance, specifically in the shipping industry. You called it an MCM, or maintenance cost model. What were you trying to kind of solve for, and how do you think that has ended up being helpful in the business itself?
Yeah, so you're talking about the paper that was done by the research of Sietske Mussalt. What we wanted to achieve there is to look at, okay, if an incident happens, or if we say, yeah, in our FMICA studies on a criticality analysis, we say for certain systems, if this fails, then this is the consequence. And in that model, we could go more deeper in looking at the location where the ship was, but also in what kind of cargo trade was the ship at that moment. And looking then if we would still be able to load a full cargo or half a cargo, and what then was the consequence in cost of that failure.
Okay.
So we took a lot more information into account.
So it sounds like you take a very data-driven approach to the way you all do kind of maintenance and reliability. Would you say that's accurate?
Yes, it is accurate that we use a data-driven approach, but I also have to be honest there that the quality of our data is sometimes not sufficient enough to use it in a model. And in that case, we use an expert group. So people from the ship, like the engineers from the ship, the vessel managers from the office, a safety and quality officer, and together with the reliability engineer say, hey, if this happens, what are the consequences? And looking at the data, part at the data what we have, but also at OREDA data and other sources. And actually what is in the brain of the people.
Which you just kind of mentioned data integrity issues, and that it's hard to get accurate data. What are some of those challenges that you find in just making sure you have a complete and accurate data set?
One of the challenges is there that we have less than 10 years of maintenance data in our current CMMS system. And that doesn't match one-on-one on the old data from the previous system, what is also difficult to access. Another big challenge, what we are working currently on to improve, is how do we report maintenance done and how do we report defects? Do we report it on the correct system, and do we actually report the usage of materials? Those are some challenges in that one.
Yeah, well, and I would think with such a mobile workforce, it probably compounds it even more because the fixes are so critical, right? When you're out at sea, you just have unique challenges. It's like do it, and then obviously you want that data and that reporting accurate, but I'm guessing that that also creates some of the challenges. And it's interesting thinking about, as AI gets more important in various businesses. I like that you said you still use the brains of the people. Our point of view is that as technology and as AI improves, that's really just going to help those experts even more, not replace them. It sounds like that's probably the perspective that you have as well.
I think we still need the human sense and the human knowledge on making links. There's a lot that technology can do, but the biggest challenge is there is not implementing the new technology or new tools. It is actually getting that human, our colleagues and myself to work with it and to change something in our behavior in that. And a real big challenge we have today is not on the technologies and on the data, but because at the end there will be tools to get this right. But getting that in your culture and getting that be a different way of working, a different way of behavior, there is for me the biggest challenge.
Yeah, just the change management process, the human aspect of implementing technology. And I feel like that's almost always the challenge for sure. I did want to ask you about, so our company, we do root cause analysis. We have a software platform that does root cause analysis. How important is root cause analysis in your business? How frequently do you do those? I'm just curious how your company handles that.
Well, as I mentioned, we have a technical incident investigator in our team, what already shows how important root cause analysis are for us. And the reason we started with a dedicated role on this is that we saw a lot of unexpected failures and actually didn't have the capability to learn fully of those and to implement those preventive actions and learnings. So for us, it's very important to have good root cause analysis, but also to help our people on board and our operational teams what information is needed to make a good root cause analysis. So it's not something you do alone, but you have to do it together. So for us, it's very important.
It's good. Yeah, and it sounds like you have a team approach and you feed those answers back into the business so that you're avoiding some of those failures. Well, there's a lot more we can kind of talk about, obviously. We've just really appreciated your time. I would love to hear any kind of final thing you would love to pass on to reliability engineers in particular. So we have people listening to this podcast who are maybe starting out in their careers, maybe a little further along. But if you could kind of rewind the clock on yourself, what advice might you give to kind of a reliability engineer beginning their career?
Well, what I learned over time is that for me, the key is in communication. Really, in communication, be clear of what you expect of each other. And actually, yes, I learned that during the process of being a reliability engineer, but also by learning that from a very young horse. Because if 500 kilos doesn't understand you, you get a lot of mess.
That's good. I love asking that question of people because it usually the answer comes down to not the most sophisticated thing, but like a basic. It's incredible how if you get the basics right, so many other problems sort of take care of themselves.
Yeah, and what I forgot to mention is there's a challenge if you have 28 floating assets all around the world. Try to reach them because it's not easy just to drive or fly to a site and have a look because you don't
Absolutely.
know if you're not always sure if they will be there.
And that's what I was thinking about when you said you have 28 ships and they're all over the place and something breaks. I'm like, it's not like, yeah, like you just drive to that plant and you overnight it. It's like, no, you got to probably get a helicopter or something, right?
You rely on the people on board. So where normally in a plant you would say, okay, I will call a service engineer. In some cases you cannot get that service engineer. You have to fix it on board. So the person who prepares the work, you're the warehouse manager, you're the one executing the work. You're everything in one. So
Yeah,
yeah,
I
I
mean,
think that's the challenge what you have on board. Of course, we have quite a good spare part stock on board
right.
and to overcome the most difficult issues. So, and there are enough safety systems to manage that. But there can be moments that you say, yeah, now we really have to first get to the next port and we have to fix something.
Right. Well, and you need real problem solvers on those ships, right? Because they're going to have to take care of things that you didn't necessarily have the textbook and all that ready to go.
If you're trained as a marine engineer, your knowledge is very broad because you have to know the electrical system, the automation system, mechanical rotating. So there's a lot more. On the other hand, you have also 3 colleagues together, 3 or 4 colleagues where you can ask something to. So
that's good. That's good.
We have 3 engineers to 4 engineers on board most of the ships. Yeah.
Good. Well, Esther, thank you so much for being on this. Again, we've been talking to Esther Voort. We really appreciate your time. She serves as the reliability manager of Anthony Veder. And so we do appreciate it. Thank you for being on the podcast.
Thank you for having me.
Great. And to all listeners and really anybody, we're here to help reliability engineers and really anyone learn and take steps to being more successful at solving problems and using technology in that process. Of course, if you're looking for RCA training or materials, check out reliability.com. And of course, if you want a software platform to help you do root cause analysis, check out Easy RCA. Well, that's all the time we have today. Thank you, and let's go forth and make the world a more reliable place. We'll see you on the next episode. Take care.